So in this video, I'm going to talk about inverse functions, and this is going to be part of a series on the algebra behind inverse functions. And the first thing I want to do is actually define what it means for a function to be one-to-one and to be able to determine if a function is one-to-one. So first off, let's review what a function is. It's a relation where every member of the domain has exactly one output. So what we mean is that every x value is only going to go to one y value. We don't want it to go to two different y values. That's a no-no. And to extend this, when we talk about what one-to-one is, we talk about it being a function, first of all. So it's not just any relation, it's a function. So every x has to go with one y. There are no two members of the domain that have the same y values or the same outputs. So I always think about this with a relationship. If a relationship is one-to-one, for example, if we're talking about people dating, then neither of the people is dating anybody else. Now, there are situations I know out there where people will date others while they're seeing one person. Well, when we talk about being one-to-one, we're talking about a couple that's exclusive. They're not dating anybody else. So this is also known as being injective. That's the name that we have in math. And this is equivalent to saying that if f of a equals f of b, or if my two y values are equal, then that automatically would mean that my two x values are also equal. The only way to get the y values being the same is if the x values are the same. Now I'm going to go a little bit further and talk a little bit more about some of the tests that we would use to see if something is one-to-one. So the first one is the vertical line test. Now what we're going to do is draw a vertical line, and that's going to tell me if a relation is a function if I can draw a vertical line and it only touches the curve in one place. There is no vertical line that can be drawn that touches the curve more than in one place, one point. And the horizontal line test is going to add on to that. So we use the horizontal line test to test if a function is one-to-one. And it works pretty similarly by doing a horizontal line instead of a vertical line. So if there's no horizontal line that can touch the curve more than once, then we can say it's one-to-one. If the horizontal line touches it more than once, we know it's not one-to-one. It can still be a function, but it may not be one-to-one. All right, so let me keep going. I'm going to talk about a couple of quick examples here. So is the relation a function? Now notice this is a set of points, x's and y's. And if it is a function, is it one-to-one? So the first thing I want to do is it a function? That's kind of the first thing we need to check off the list. Well, I can tell you right off the bat that this first example, this first relation, is not a function because our x value of 9 not only goes to -2, but it also goes to -3. Now, I know right off the bat that's not a function because every x value should only go to one y value. Now, since it's not a function, I know that it's also not one-to-one. It can't be. Now I'm going to look at the next one. The next one, if I check out all my x values, I have 8, I have -6, I have -5, I have 4, and I have 3. So no x values are repeating. They're not going to any different y values, so I know that's going to be a function. Now the second thing I'm going to check is, what about the y values? Well, if you notice, I have 8 and 8. That's a problem. In this situation, these two 8s go to two different x values. So this 8 goes with that 8, and this 8 goes with -6. So that tells me that this is not one-to-one because those 8s are seeing those other x's. They're connected to them. Now, the last one I'm going to do is I'm going to check real quickly again to see if it's a function first. That's what I always want to check first. So I'm going to look at those x values: -7, -6, +6, +7, +4. None of those x values repeat. No x's go to any different y's, so I know that that's a function. The other thing I'm going to do again is now if I want to see if it's one-to-one, I'm going to check those y values. We've got -1, we've got +7, we've got -8, -7, and -4. Since none of those y values repeat, since none of those y values went to a different x value, we know that it is also one-to-one. Now, a couple of things that people always ask me is, what about this -7 and that -7? Well, that's okay because in this situation, this is a x and that's a y. That's not an issue. I only have to worry about if the x's are repeating or if the y's are repeating to different numbers. Now on to example number 2. Again, it says, is the graph a function? If it is a function, is it one-to-one? So I'm going to kind of follow the same process here, only this time I'm going to refer back to those tests. So the first one is, can I pass the vertical line test, also known as VLT? If I draw a vertical line, how many places is it going to touch that curve? Well, if I look kind of in a few different places, if you notice, I'm drawing vertical lines and it's only touching it in one place. Well, if it's going to pass the vertical line test, I cannot be able to draw a line that touches it more than once. And in this case, that's true. There's no vertical line that can be drawn that touches it more than once. On the other side, I want to do a horizontal line test. So I'm going to check if there's a horizontal line that touches this more than once, it's not one-to-one. And if you notice right here, the x-axis touches it in 3 places. Touches it once, twice, 3 times. That's definitely more than once, so the answer is no. It is not a one-to-one function. Now on the next one, if I draw a vertical line, I'm not touching it more than once. And in fact, there's no place where I can draw a vertical line that will touch it more than once, so it is a function. And the same idea with the horizontal line test. I can't really draw any horizontal line that touches that original curve in more than one place. All right, so that is going to be a one-to-one function. And this last one, this kind of S-looking curve. Well, if I draw a vertical line, let's do the y-axis. I am going to touch it in 1, 2, 3 places. So this fails the vertical line test. It is not a function, which automatically means not one-to-one. The last thing that I want to do is use algebra to show that the equation y equals x squared is not one-to-one. So what I want to do is I want to check the idea of if I have 2 different values for a and b, 2 different x values, and I plug those in and get the same y value, then a and b actually do have to be the same number. Is it possible to have the same y value from 2 different x's? And so I'm going to use algebra this way. So what I'm going to do is I'm going to treat this y as f of x. And so what I'm going to do is I'm going to start off with kind of that statement of f of a equals f of b. And I'm going to plug it in. So I'm going to do a squared equals b squared. Now, I'm going to solve for one of these variables. Typically, most people just solve for a. And the way that we solve for a is that we take the square root. So I'm going to take the square root of a squared, and it's going to give me the square root of b squared. And I need to remember plus or minus. Well, the square root and the squared will cancel, so I'll get a equals plus or minus b. Now, if this were one-to-one, I would just get a equals b. Well, in this case, it says a equals positive b or a equals negative b. So I know at this point that it is not one-to-one, and I have the algebra right here to prove it. Another way you could think about this, again, from the standpoint of kind of numerically using algebra, is if I take the number 2 squared, we get 4. And if I take the number negative 2 squared, I also get 4. So notice here I have 2 y values that are the same, but x values that aren't. So that's another way I know that it's not one-to-one. That's just not really using my algebra skills. Hopefully this does help you better understand the idea of one-to-one, because in the next video, we're going to use that idea to talk about inverse functions.